host, Carol Gabica, Vice President of Digital Aviation for SmartSky. Go ahead, Carol.
Thank you so much, Jana. And on behalf of SmartSky Networks and our partner, Meandair, welcome to the MBAA Schedulers and Dispatchers Conference, and to those of you that are joining us from other locales. SmartSky Networks is honored to present to you today a pre-launch live demonstration of truly global METAR TAF information provided by our partner, Meandair. As you all know, in aviation, METARs and TAFs are extremely significant. And as you'll see from this presentation, what Meandair has put together is something that is unique in all of the industry. Meandair is one of 3 SmartSky Network partners who provide unparalleled predictive weather as a part of our SmartSky Predictive Weather Suite. It is now my pleasure to introduce you to Antonin, the CTO and Technical Director of our partner, Meandair. Antonin?
Thank you very much, Carol. And thank you all who are here for your time and for the opportunity to present you our latest development on the airport weather service we are creating. So my name is Antonin Komenda. I am from Meandair. We are a company from the Netherlands, from Europe. And as Carol said, this demo will be live. So all the weather you will see, all the information you will see will be live. And the global coverage, as you see from the screen now already, is currently in pre-launch phase. So all the data and all the technology is running live, but we plan to announce the live launch soon of this product. So I will take you through the service. I will show you some details and some particular information about the weather and how we produce the weather. And I will be showing it on different regions and different areas. And as I said, the data are live, so that means that the demo will depend on the weather, literally in this case. So hopefully we will see some interesting weather which is currently happening somewhere around the globe. So let's dive into it. Here you can see an overview of METAR information over the whole world. So you probably saw products like that. This information are color-coded as usual. So we are using the standard 4 colors for the flight rules, which can be used at that particular places, which are based on the weather conditions at that place. And the colors go from green, which represent the visual flight rules, to blue, which is the marginal VFR, instrument flight rules, color coded by red, and low IFR by purple. So as you can see, we have a couple of dots here. These dots represent airports or places which are equipped with the meteorological devices which are producing the METAR information, or they have even meteorologist who is issuing these meteorological observations for that particular time. So now I will zoom at one of the interesting regions, which is for us here for this demo, India. So India is interesting by the fact that it's a large country, although the number of the airports which are equipped by the meteorological stations is not so large. So as you can see, there is not so many dots. And on one of the dots, which means at one of the airports, I will show you and describe you what meteorological information we are talking about here. So I will open this particular airport, and soon we will see the visual decoding of the matter information for that particular airport. Yeah, so this is it. You also probably saw visualizations like that. So it begins with the textual METAR. In this case, it's this one. And this textual form of the weather information can be decoded. Pilots for sure knows representation like that in the text form, which is practical for communication via radio, for example, or other devices on board of their aircrafts. So as we can see, the decoded information contains stuff like sunrise and sunset times, the pressure at that particular position, location, sorry, the temperature, the ground visibility, and the information about ceilings and about the wind, and then the overall flight conditions for that particular airport, which in this case are marginal VFR. Currently, the weather at that place doesn't have any ceiling because the clouds are only scattered. So by definition, scattered clouds do not form a ceiling. So we have no ceiling. If there is a ceiling, we would see also the height of the ceiling, and we would also see what type of clouds the ceiling is formed by. And we can see the visual decoding of the wind with the direction, strength, and also the headwind and crosswind components of the wind for a particular runway in this case. So that's the visual decoding of the METAR information. And similarly, we do visual decoded information about TAFs. So in this case, we have also the textual representation of a TAF, and we are decoding it in a form of +5 hours maximally. So every box represents +1 hour. And as we can see, the conditions are changing during the time. For example, sorry, for example, at T0 +5, we can see that the conditions changed from marginal VFR to IFR in this particular case at this particular airport. So this is something which you probably saw from other services and from other meteorological information sources. What is unique for our system and this particular application is that we can provide such information not only for the airports which are equipped by the physical device, meteorological device in this case, but we can provide it for all the airports which are at that area. So as you can see, there is much more colored dots here, and these colored dots represent all the airports which are in India, even the smallest one which you can find there. The important information here is that, as I said, India is a big country. And for example, the difference between the airports which are covered by METARs is only 95, but the number of all airports is 605. So the coverage is really low, and we are providing the coverage for all the airports. So now I will open that same airport again, and we will look at the data we are providing via our system. So if I switch the data to visualization of our nowcasting-based METAR information, we can see practically all the same information here. So we can even compare what the METAR from that airport says and what our nowcasting system says. So what's a nowcasting? So weather nowcasting is a technology which can create technically a weather forecast, but the forecast is for the current timestamp, let's say the current time. And because we do this for the whole globe and for all the regions, we can exactly build this METAR-like information for every place on the globe. So in this particular case, we are doing it for the same airport as we saw from the information from METAR. What we do as well is that we not only create the weather nowcast and then visually decode it, but we also create AV METAR, which in our case is airport weather METAR, information similar in the same form and the same syntax to METAR. So it has the same benefits as classical textual METARs, which can be communicated by the radio or by other applications, for example, using the textual form of the METAR. But also it provides more information than the classical METAR. So for example, the preciseness of altitudes of the ceilings, if there are some, or the information about the wind is more precise. Additional to that, as you can see here, the data age of the METAR is 45 minutes. And that's also the reason why our system, our nowcast, says that the conditions are VFR, but the METAR says that the conditions are marginal VFR. The difference is that the METAR was issued 45 minutes ago, so the data are much older than our data, which are recomputed every 15 minutes and refreshed every 5 minutes. So the data we are providing are much more timely and provides much closer view at the weather at that particular location. So that's the reason why the data can be different and why the nowcasting we are doing is of higher quality. So that's information METAR-like, and we are doing the same thing for TAF-like information. Again, we are producing textual form, and also we are producing the visually decoded information. As you can see, for example, here, the cloud condition is differing for the +1, +2, and +3 hours. So there are some scattered clouds here, then the sky should be clear, and then again, there will be some scattered clouds, and then the sky will be clear again. And also the wind direction is changing slightly, as you can see in these directions. And the strength of the wind is also changing. So you can see that the prediction is of higher quality because, for example, here, the classical TAF is keeping the same value for longer time because the prediction is much more coarse, let's say, for this particular airport. The data age for TAF is even more pronounced. So we are producing the TAF information in the same rate as the AW METAR information. So here, our data are currently 70 minutes old, and the issued TAF is 2 hours and 17 minutes old, which is much, much older than the nowcasting we are doing for that location. Not only that we are doing this information for airports which are equipped by the meteorological devices, but as I said, we can cover whatever airport, even smaller ones. So now if I look again at the airports which are providing METAR, and I will try to find some smaller one which is not providing METAR, I can see again the same weather information for that particular airport, but I cannot switch to the METARs because there is no METAR station there, but we are still providing information for this place. Now, we are not using only some simple finding of the closest, for example, METAR station or some simple interpolation. We are doing real meteorological nowcasting for that place, which means that we are taking all the sources of the weather we can, and we are building the prediction model out of the data and using this model to create these AW METAR information and the 5-hour prediction for all the places. So that was for smaller airports. And not only that we can do it for smaller airports, we can do it also for arbitrary longitude and latitude, places. So for example, we can do it for drilling platforms or even for moving ships and other places which can be, for example, used for landing helicopters and other operations. So that was the demonstration of the coverage by the AW METARs and AW TAF. So as Carol mentioned, the big announcement is that we are providing the data globally currently in this pre-launch demo. So for over a year, we are supplying this data to our customers in Europe. And we have really positive responses from them. They are using it for different operations, typically for flying with smaller airports, but also we have a couple of customers of bigger airports which are using this information, for example, as a backup to their physical meteo stations or to just get another information about the weather from different sources. So now, since we are covering the whole world, we can provide this information to other places. And as I was talking about the weather, these weather models are providing also the classical meteorological views, let's say, in this case, on rain. We are doing it also for cloud cover. So you can see that we are doing the prediction for cloud cover. And we are also doing special prediction of thunderstorm systems. So again, this type of data we can provide to all regions currently. And the last piece of information, which is also pretty important, is what's the quality of this nowcasting. So we run an independent comparison of the quality of the data from the classical METAR stations, and we compare it to at places where there are METAR stations to our nowcasting system. So the classical METAR stations have 83% of correct prediction of the current weather at that place, if taken in hindsight. And if we compare this 83% to our nowcasting system, we are getting with our data to 81%. So the quality is really high and is on a par with the physical meteorological stations at those particular locations. The measurement was done using the standard quality measurement, how it is defined by the METAR documentation or the METAR specification. And we were doing it together with university researchers who are specializing on these metrics and comparison of METAR data. So the last visually interesting point which I would like to show you is that we are looking at India, at Europe, at US, but maybe really interesting is also South America. So here we are looking at Brazil. So you can see that there is not many dots of the real METAR stations, But if I switch it to AW Meandair, you can see that there is a lot of small airports, and our product can be of high value exactly for these places which are not covered by any other METAR stations or other meteorological devices which can be used for flying among these small airports. So South America is also a nice example where this product can be of high value for the pilots or for the operators of the airports. So that was my presentation. Thank you very much again for attendance and for your attention. And if you would like to schedule a private demo, or if you have questions, please don't hesitate to contact Carol at weather@smartskynetworks.com, and we will gladly answer all your questions and comments if you have to this product.
Thank you so very much. I appreciate your presentation, and I appreciate all of you who have joined us. Again, if you have any questions or if you would like a private demo, just reach out at weather@smartskynetworks.com. Thank you all for joining us.
This concludes our webinar. Have a great day.
I think it's just us. Are you there, Jenna?